Today's assignment is very similar to yesterday's, except instead of 2 equations, we're going to have 3, or in a couple cases, actually 4. So if I had 4x plus 2y minus 6z equals 8, and 3x plus 4y minus z equals 2, and x plus 4z equals 3. How would I put that in my matrix? You would enter a 3 by 4 matrix, you would put all of the coefficients, and you would do RREF. And your answer is going to look something like this. 1, 0, 0, 0, 1, 0, 0, 0, 1, and then 1, 3, negative 2. This would be your x value, this would be your y value, and this would be your z value. Okay, hopefully that's review and you guys understand that. In the linear algebra class I talked to you about yesterday, you can have a matrix with 30 variables, but we run out of letters pretty quickly. So once we get beyond x, y, and z, we tend to just call them all x's. So on these two problems, you won't see x, y, z. What you'll see is x1, x2, x3, x4 equals something. Then x1, x2, x3, x4. So we just call them all x's. We just number them 1, 2, 3, and 4. What's that? Oh, yeah. Okay, now the tricky thing is, how do you know if you have infinite solutions? If the bottom row is all zeros. So if your matrix has that pattern, you know that there is one answer. It's the point 1, 3, negative 2. Okay, but if you have a matrix and you have something here and 0, 0, 0, 0, that tells you that you have infinite solutions. Okay, just that one problem. What if you have this? That would be no solutions. Now, when I graph a 3-variable linear equation, what am I actually looking at? What does the graph look like? It's in 3 dimensions. So we have an x and a y and a z, but what does an x plus y plus z equation look like? It's no longer a line. It's a plane. Okay? So, what if I have this? The middle equation is 0, 0, 0, 1, and the bottom equation is 0, 0, 0, 0. So the middle one is telling us no solution, but the bottom one is telling us infinite solution. Which one wins? Well, let's think of planes, okay, like flat surfaces. So this is telling me that these two equations are identical. So it's like graphing the floor and then another copy of the floor, so they touch each other everywhere. But the third one, that middle equation, is parallel to the other two. So it would be similar to having 2 copies of the floor and 1 copy of the ceiling, which is no solution. So if you have both an infinite and a no solution at the same time, no solution wins. Okay? And in every other case, it would be like graphing the floor and the back wall and the side wall. Do the floor, the back wall, and the side wall ever meet? Yes, in one place. It's that point over in the corner. So if I were the origin, my feet were the origin, it would be like 16 feet to the right and 0 feet up and 14 feet in that direction. So the point would be 16, 0, 14. Does that make sense? So everything today is going to be done using RREF, and you either have 3 or 4 equations to deal with. Now, sometimes you'll run into a tricky one like this. X plus 2y equals 3, and y minus z equals 4, and x plus 4z equals 5. How big is this matrix? It's not 3 by 3. It's still 3 by 4. The trick is there is a 0 in every equation. So this one would be 0z, this one would be 0x, and this one would be 0y. Okay, you can never have a square matrix when you're doing RREF. Well, sorry, I guess you could put it in, but if you're solving linear systems of equations, the matrix will always be one longer than it is tall. So you'll never have a 3 by 3. It will always be a 3 by 4, or a 4 by 5, or a 5 by 6, or so on. Okay. Yeah, sometimes in the book they leave spaces to remind you that there are missing numbers. Yep. I didn't assign any of those, did I? So Nate's asking, what if I have this? And then so these are two planes. So it would be like graphing the floor and the back wall. How many places do the floor and back wall intersect? That whole line right there that's infinite, right? So the answer is going to be infinite solutions, and you would put it in as a 3 by 4 matrix, but the bottom row would be all zeros. Well, because we're trying to find the intersection, so you would have the bottom row would be all zeros, which tells you that they intersect in an infinite number of places. But what Cynthia wants you to do is to find the intersection. And you can do it algebraically. It's harder to do on your calculator. But you can simplify it down. You can kind of put them together, and you'll end up with, instead of points, you'll end up with an equation. And that equation turns out to be the equation of the intersection. So if you have 3 equations, you can simplify it down to a single point. If you have 2 equations, then you'll end up with something like this. You'll substitute or eliminate or use some kind of matrix operation, and you'll simplify it down, and you get something like this: x plus y minus z equals 1. And this is the intersection. That is the solution. Right? But there are an infinite number of solutions, and we don't really care, so we're not going to do those. Okay? So if you have 3 variables, you need 3 equations to solve it. Otherwise, when you solve it, you just simplify it down to an equation. And frankly, we don't care what that equation is. Not in this class. Okay. Good luck.